Okay, so I'd like to welcome everyone here to the third online seminar on innovating for sustainable raw material value chains. This is organized by the BioRecover Project, which is a research project on sustainable extraction technologies financed by the European Commission. And today we'll be focusing on the geological aspects related to raw materials. And our discussion today will be focused on researching unexploited European reserves. So on the agenda today, we'll have a few opening remarks that I'll be presenting just to set the context for our discussion on mineral exploration today. And then I'm very excited to hand the floor over to three experts that will be taking part in our panel discussion today and who have been gracious enough to offer us their time and insights. So first, we'll be hearing from Blandine Gorcerol from the French Geological Survey, BRGM. Blandine is an economic geologist specialized in Precambrian ore geology, gold, and lithium mineralization, and she'll be presenting her work in the Ion for Raw project. Next, we'll hear from Vesa Näkinen from the Geological Survey of Finland, GTK. Vesa is a research professor at the Geological Survey of Finland and an adjunct professor at the University of Helsinki. He also coordinates the EIS project, which he will quickly present for us today as well. And then Vesa and Blandine will be joined in a panel discussion by Dr. Klemen Teran from the Geological Survey of Slovenia. Klemen is the head of the Department of Regional Geology at the Geological Survey of Slovenia, and he is also the co-chair of the EGS Mineral Resources Expert Group. So for those in the audience, you've also just received a poll that we've sent out. So the idea here is if you could just quickly fill that out, that will give us some insights into who's been attending today and really help us work towards making sure that we're tailoring the content that we're presenting to the level of expertise of our audience. So thanks for your engagement on that. So to start our discussion, I hope everyone in the audience can see my screen as well. I wanted to present a few quick facts and figures about where we stand in terms of supply and demand of the metals that are going to be critical to the energy transition as we go towards 2050 and the net zero ambitions that Europe and many countries around the world have set for themselves. So something that we've discussed extensively in the previous two webinars hosted by BioRecover this past week is that the global energy transition is driving a rapid expansion in demand for a wide range of different metals. So today I've got a few figures for copper supply and demand, because for those who might know, copper is something that is essential for electrification. And so as we're expecting to electrify our transportation systems and move towards a renewable energy grid, and as we see increasing demand from developing countries around the world, as more and more people move into the middle class, we're expecting that global demand for copper is going to double by 2050. And as you can see here in these figures presented by, so some people are not seeing the screen. I'm just going to quickly try to stop sharing and reshare it again. And hopefully that'll fix the problem. And those in the audience, feel free to let me know if you're having any technical issues, and we'll try to get right on top of that. Okay, great. So as I was mentioning, there's a real challenge facing the planet in terms of how we are going to match global supply of the energy, critical metals for the energy transition with rapidly increasing demand. And so here we have some figures from S&P Global, where they've shown that if we are not able to have a high ambition increase in global copper supply, we're going to face quite significant supply gaps by 2030 and 2035 as we expect to build out the new infrastructure needed for the energy transition. And so We know now that we need to rapidly expand supply, and yet something quite curious has been going on in the mining industry, which is that major mining companies around the world have not been investing heavily in exploration for new greenfield deposit sites. And so here we have some more figures from S&P Global showing that in the years since around 2015, copper miners have really not been investing very heavily in exploration. And typically when major mining companies do invest in exploration, it's really focused on expanding existing mine sites and not necessarily on locating new greenfield sites or new sites that have no mine near or around them. And at the same time as we're seeing this global phenomenon of kind of an underinvestment in exploration to bring on new supply in the future of copper and other major metals that we'll need for the energy transition, we see that the mining industry is facing extremely long lead times in order to go from actually identifying a deposit to producing metal from that deposit. So here we have some figures from the International Energy Agency, which show that on average over the last 10 years, the time it took between the discovery of a new copper deposit and the actual production was on average 17 years. And we see here that the majority of that 17 years was in the exploration and feasibility phase of that, with actually relatively little amount of time dedicated to constructing the mine itself. And so if Europe is going to bring its supply of critical materials in line with its ambitions to reach its climate goals, this is something that we're really going to need to address. And so we're going to be focusing on these topics further during the discussion, but for now I'd like to hand the floor over to Blondine from BRGM, who will be presenting her work in the Ion for Raw project. Blondine, if you'd like to share your screen, the floor is yours.
Thank you very much, Sam. So can you hear me correctly?
We can hear you fine, yep.
Okay, perfect. Can you see my presentation?
Yes.
Yes.
Okay, perfect. So thank you very much, firstly, for the invitation today. I'm very pleased to introduce you to the Ion for All project, and especially on the aspects regarding the European potential for metals. And so just a brief review of the Ion for All. It's an European project which aims at improving the sustainability of critical raw materials extraction and to improve recovery of critical raw material and strategic raw material as byproduct during gold, copper, silver, lead, and zinc or treatment processes using ion metallurgy processes. The project is coordinated by IDENA in Spain, and there is 13 partners on 8 countries. We study Cononish in deposit in Scotland, Cobre las Cruces and Valle Buenas in Spain, and El Porvenir and Cerro Lindo in Peru. For this project, 10 targeted byproducts are studied, including the antimony, bismuth, germanium, indium, cobalt, tellurium, selenium, molybdenum, rhenium, and platinum, which are strongly involved in the economic growth and energy and ecological transition. And so for most of them, they are critical at the European scale, and some of them are critical at the country scale more than at the European scale. So what is critical regarding this byproduct or targeted byproduct metals? Some of them are considered as small metals, not because they are small, but because they are occasionally meet in base and precious metal deposits, and they could be produced from processes or complementary processes applied to deposits. And one of the key aspects and one of the first step of the project was to produce a geographically based compilation of the byproduct occurrences and potential in Europe using European datasets. And for this, we use European bromine datasets, as you can see on this map. So let me just put the. So this represents the bromine dataset where we have 8,000 identified occurrences and deposits in Europe. And only regarding the copper, gold, silver, lead, and zinc deposits and occurrences, only 1,400 deposits were identified. And not in all of them, the targeted metals were met or identified in the past. So one of the key aspects was to perform a predictive assessment to identify potential at the European scale. And to answer this question, we use the database querying method, which is a method developed by the Belgium to perform predictive assessment on datasets to identify the potential presence of target byproduct elements where they have not been historically searched or described, and the favorability is based on the similarity to a characteristic multi-element signature derived from deposit and mineral occurrences of a specific type, such as the metallogenic family, that may contain the targeted commodities. And so based on this, we have produced the maps of kernel density of ponderated elements scores at the European scale. This is an example of bismuth, cobalt, and germanium, and where you have high potential in red color, you will be potentially meet deposits of economic interest regarding the metals or the targeted metals. And so one of the advances that we have developed through the project was to use the element association of the several metals to predict a metallogenic family at the European scale. This was just a very brief presentation of the project. And if you are interested, there is links if you want to see more input of the Iron Forum. Thank you.
Thank you, Blondine. So we'll hear more about the Iron for All project and your work in the discussion. But for now, we're going to hand over the floor to Vesa from GTK, who will be presenting EIS.
Okay, thank you very much, Sam. And thank you very much for invitation. So I hope you can hear me well and see the presentation as well. So in this talk, I will introduce the main concepts of the project, Exploration Information System, and the innovations and the added value that we bring via this project. The EIS project is a European Union funded research and innovation initiative, which is aiming to combine mineral systems modeling together with mineral prospectivity analysis methods, which are aiming at finding new sources for critical domestic primary raw materials within the European Union. With emerging exploration data, the need for efficient data analysis is really essential. The data is expensive and there is need to get most out of it. Artificial intelligence, including machine learning algorithms within GIS platforms, have made it possible to combine the geological knowledge and exploration data into complex mathematical models that can be used to make predictions for existence for new mineral occurrences. This EIS project is a pan-European project that has partners from 6 EU countries and also 2 partners that come outside of EU. The EIS project is operated by a consortium which has totally 17 partners from leading research institutes, academia, service providers, and mining industry. This is a 3-year project, and we have already run this project a year, so we have 2 years to go. And this is aiming to develop innovative mineral exploration concepts and data analysis tools. We are focusing on enhancing the probability of finding new sources of critical raw materials for EU's economy. So this is the consortium. Geological Survey of Finland is the coordinator. This is a well-balanced consortium, 50% of research and academia, 50% of companies. We have geological surveys, we have universities, SMEs, and industry partners in the consortium. EIS project will develop a toolkit and a wizard for OpenGIS platform. And this platform is QGIS. These tools will be freely available for the industry and also for the academic users, for everybody. The tools will be freely available for and the tools will be developed to aim to reduce the impact of the exploration and making it therefore more sustainable. It will reduce exploration footprints by using the existing exploration data and by making exploration faster and more efficient. So one of the main aims is to save time, to make the exploration process much faster. Furthermore, EIS project will also raise awareness of the importance of critical raw materials to the EU's transition economy and welfare. EIS project is an environment for performing mineral exploration related data analysis and modeling, for managing data and other information, and for representing results in different forms. The fundamental basis of this is the mineral systems library. So we are doing geological research where we are defining the critical parameters for mineral prospectivity analysis. And central part of this project is this scientific research on these mineral systems modeling and mineral systems in well-selected study sites, and which comprise known mineral deposits. And these will be used for studying geological, geochemical, structural, and mineralogical characteristics of these deposits. So the study sites of the project are spread across Europe, and these represent the main metal producing regions of Europe, including Fennoscandian Shield, Iberian and Central European belts. The mineral deposits in the belts are the most feasible sources for critical and high-tech and other economically important metals in the EU. In this project, we are promoting the utilization of hybrid approach of using both mineral systems modeling as a basis for mineral prospectivity modeling. So we combine these two approaches. We have selected to focus on 3 different mineral systems. We have cobalt mineral potential in VMS systems in Czech Republic and Spain, lithium, tin, tantalum, tungsten minerals potential in granite pegmatite related systems in Sweden, Finland, Germany, Czech Republic, France, and Spain. And finally, rare earth cobalt mineral potential in IOCG systems in Sweden, Finland, and Spain. So quite a few target areas to study. In addition, we have reference study sites in South Africa, Orange River Pegmatite Belt, and in Brazil, Carajás IOCG province. So this was EIS project in brief. And thank you very much for your attention, and more information about the project can be found from the project website, or you can send the email to me. Thank you very much.
Thank you very much, Vesa. That was a really interesting overview of the EIS project. And so now I think we can move straight into our panel discussion. So we'd like to start with the question first for Clement, since we haven't heard from you yet. Clement, we were hoping that you could give us an overview of the relationship that you see between your National Geological Survey and the mining industry, and what role you think national geological surveys can play in promoting a more sustainable mining industry within your respective countries.
Okay, thank you, Sam, for word and for invitation. I'm very happy to be here. So I see national geological surveys in the loop, in the three-part role. First role is to maintain and provide basic geological knowledge on the national level. So to know geology, to know prospective criteria and so on, and to attract investors, or to give investors a basic knowledge to where to go for the permitting and so on, and also to inform national and EU policymakers about the data and to harmonize those data. Then the second role I see in geological surveys is related to public mining service. So when the investor go to the exploration or exploitation, then you need to monitor their activities. So at least in Slovenia, we have done this public mining service, and then we got the data about the production, about everything, and then to fill this mineral yearbooks, which are very important documents also on the political level, and to monitor if the activities are according to professional standards. And then the third role is to collect the data back from the projects, from the exploration, from the exploitation, to upgrade the knowledge about the models, about everything, to know in which direction then go forward, and to harmonize them on the EU level. Now it's we talk a lot about UNFC classification to be a standard on the European level, and to fill this European mineral yearbook to make strategies which are then more focused on some topics. And then additional to this, I see a very important role also in secondary raw materials, which are a big topic right now also, and can be source of many critical raw materials. And this is a way to be much more sustainable.
Great. Yeah, thanks for that overview. I think you've already gotten us started on the next question, which is when you mentioned the fact that you're supporting investment in exploration and kind of helping the private sector understand where it's more or less reasonable to search, and then also monitoring and to make sure that those activities are carried out in a sustainable way. I was wondering if Vesa, you wanted to jump in to maybe expand on the role that EIS or your work at GTK can play in driving further exploration for critical minerals from the private sector as well.
Yeah, in our project is aiming to provide new tools for both for industry and for research community. But if I go back to the role of national surveys, I think the main role for us is to, as I'm also from the geological survey, our role is to provide, as I see, is to provide the national data and maintain the data, as was mentioned already. And GTK has been rewarded many times by the Fraser Institute by its excellent geodata, and industry really considers it very useful. But what we are aiming to do now is also to provide new tools so that there will be added value, not only giving the raw data, but also tools to get more out of the data. So that's something that we try to do via this project now.
Mm-hmm. Great. Blondine, I know you also mentioned in your presentation that when you're identifying byproducts, potential locations of byproducts, that you're also taking into account where they might be most economically feasible. Would you like to discuss that a little bit?
We try to recently at the Belgium, we try to apply the productivity assessment on all the data sets that we have to gather more information about the assessment potential regarding the metals. So we try to see where we could have already mines and where we can just apply the processes that we are studying, especially for iron ore, where we have already mines in Europe and where we could apply the process that we developed through the iron ore project. And that may be just an asset of the project if we could apply it directly to a mining production.
Mm-hmm. Great. And would anyone like to elaborate a little bit more on how industry can tangibly use the data that your national surveys are producing? You mentioned, Vesa, that it's something that's interesting for them.
Yes, definitely. That's obviously the first thing most of the mining companies are asking when they enter the country. They are knocking our door and then they ask for the data. So that's how they know about the geology. They need the geophysics, they need all the data that is available. And that's the starting point before they start acquiring their own data, more detailed data. Mm-hmm. So the regional data is really essential.
Mm-hmm.
So it's very important to also have all historical data and to update the data all the time. And also geological surveys have the best overview on the national level, so they can consult during the whole process of the industrial developments to in which direction they should go and how to proceed.
Mm-hmm. Could you elaborate a little bit on what processes you use to go about updating that data?
Well, in our case, we have a long path to go because Slovenia has quite long mining tradition, but right now we don't have any active mining. Well, we have quarries and so on, but no metal mining. So in the last decades, our data was outdated a bit. So now we are on the path to upgrade to have this regional scale for the prospecting and everything. And also it's in the last decade, it's very important thing to harmonize data, that our data can be read by Vesa or by Blondine on the same basis, because we use different standards for the classification of the resources and reserves. And so at least in our region, we made a step forward in the harmonization, so on the European level.
If I can jump on this, we in France, we are quite on the same page than in Slovenia, and one of the challenge is to generate new data and not to manage only the historical data sets. Yeah. And it's the critical aspects that we have to do.
Because if I can develop this further, Slovenia was 30 years ago was part of Yugoslavia, where also geological survey made exploration on the national level and everything. So we had a big array of data, but after the disintegration of Yugoslavia, then there was no political will and private investors, so the sector was then in decrease. So now we are not anymore geological survey as used to be, so we will not make exploration, but we need to make this basic research on the geology.
Okay. So are your geological surveys actually going into the field and conducting exploration yourself, conducting tests, or are you more at what level are you working, I guess?
In our case, we do not do exploration, but we are doing research. So research projects, which is a bit different. So more scientific approach.
It's same with the Geological Survey of Finland. So it's not really exploration, but more regional geology and research.
Okay.
And for France, we were on the research side, but since last year, we do some acquisition on geophysics and geochemical aspects.
Okay. I had a follow-up question for you, Blondine, as well. You mentioned the importance of updating the data. So is it because previous data might be outdated, or is it more a question of harmonizing? And also related to that, something that came out in your presentation about iron for all was that there actually is no reliable data on some of these very minor metals, like bismuth or tellurium or some of these. Is that the case? And
we have to think that when we add a data in the database, it's oriented thinking. So at some point in the last decades, some metals were not of economic interest, and we changed drastically. There is a change in paradigms, and so when you drive it, we didn't identify most of the metals needed now, and so we have to rethink about the occurrences and the deposit, and re-identify the metal which are critical now, but they were not of interest again in the last decades. So we may have to do a reassessment regarding these metals, and also because in France we established the economic historical assessment of metal and base metals, but they represent historical resources. And so we have to rework and reharmonize them to today needs, basically. So this is a key aspect to be updated to the database has to be updated to the need.
Yeah. Also, if I may add, also we need to rethink what the ore is, because ore 30 years ago is not the same as the ore today. So.
And the related processes.
Yeah.
Can you elaborate on that? What you mean by the ore is not the same as it was 30 years ago?
Yeah, of course. Because in the past, only high grade ore was considered as economical viable. So let's say in the case of copper, I don't know, 100 years ago, few percent of copper was only considered as ore. But with the exhaustion of the ore, these high grade ore deposits, and with the development of this technology, then the grades dropped. So we can process much lower grades, and let's say for copper that's a 0 point something percent, which is now already considered as ore, and these porphyry copper deposits are now the main producers of the copper, but that was not the case in the past. So it's why it's very also important, the secondary raw materials, because they may contain a very high grade of some elements, CRMs or base metals, because they were at the time of the exploitation, they were considered as a barren material or low grade ore, which was not feasible to work with.
Yeah, that's a very interesting point. So does anyone would anyone like to bounce back on that? The changing relationship, I guess, between what is considered a viable deposit for supply and also what materials we need economically. If not, we can move on to our next question, which was related to some of the remarks in the introduction. I'm curious if anyone has any thoughts on why lead times for new mines around Europe and around the world are quite so long. So we saw that on average around 17 years for a new copper mine. And if there's any actions that policymakers or geological surveys or other stakeholders can take to try to accelerate supply of new critical raw materials without neglecting, of course, important social and environmental considerations.
Maybe I can start regarding the geological aspect. Especially because we need new metals, and also we have to define new models, geological models, to exploit them correctly and to produce the metals from them. So we have to rethink it, which is the case for the EIS project exposed by VESA. There is 3 deposit types to the end, and so we have to redefine the metallogenic model for them to understand them correctly.
Vesa, would you like to elaborate on that? I know in your presentation you mentioned that your ambition is to simplify the exploration process.
Yes.
Can you elaborate a little on how you're going to accomplish that?
Yeah, definitely. One of the aims that we have is to make the process in exploration faster. But that could also, of course, help making time from discovery to mine quicker. But of course, at the end, the time is dependent on other issues as well. You know, there are so many other factors related to permitting, especially, and there the policymakers have a lot of things to do. And I think there's a lot of improvements in many countries, but each country has its own legislation, and there are so many differences there. So the mining companies are definitely having difficulties doing exploration in various countries because each country has different legislation. So, but what we can do in exploration is to, of course, that can be the same, and we can try to make it faster. And certain processes, like the data analysis part, it can help. And also how we learn, what we learn about the mineral systems and how to use that knowledge in exploration. That's something that we try to do in our project. But I'm a little bit skeptical if that will help in the entire process, because it is so much depending on the permitting part, which is totally different story.
Yeah. But beside the permitting and the environmental studies and geological exploration, then you have also this economic aspect, because before you go to the feasibility and bankable feasibility study, you need to perform a bunch of investment and exploration, and this take time. And I think that in the future we will not see much shorter times for the mine openings, because no one wants to open a mine which is not feasible.
Yeah, but it will always help if the exploration time is shorter.
Yeah,
if we
definitely.
If you can make that shorter.
Yeah, or if you can apply new techniques or
Yes.
earth observation or something to identify those things.
Yeah.
So for myself as a non-geologist, my question is, how can we shorten exploration? Is it by making the drilling more precise, or in what ways can we speed that process up?
Yeah, you're absolutely right. That's the aim. What we are doing in this project now, when we are aiming to analyze the data better and more precise. So we are trying to find better targets for drilling.
Okay, great.
Or to maybe also the future, maybe also in this direction, that in situ measurements in the boreholes will be possible to collect the chemical data. So because also the chemical analysis in laboratories can take a lot of time and preparation. So maybe like the downhole surveys will be possible. There are also some projects, European projects, that develop that kind of technology.
That would be really exciting as well. And in terms of the permitting aspects, do any of you in your work touch on those types of issues and issues related to the environmental impact of mining, or are those handled by other public authorities?
Yeah, we do have other experts on working on those issues.
Okay.
Yeah.
Great. So the next question on our list was, we've been speaking a lot about geological data and the way that can support bringing on new supply that matches the demand for critical materials. Do any of you see any gaps existing in the existing geological data that we have for Europe?
There's a lot of gaps.
Okay, would you like to start on some of the major ones?
First gap is also geographical coverage. So it's, if you want to have the whole Europe covered with the data, then you need the data providers. And a lot of European projects tried to collect and harmonize the data on the European levels, but we have not succeeded yet to cover everything. So we are close to it, but you have some countries with federal geological surveys and so on, and then you don't have a central point. So that is then a second point is the relevance of the data, or are the data relevant or they are outdated. So we already discussed on that a lot of data are historical and need to be checked. And also the third point is that different parts of Europe have different knowledge on some aspects. Some have a lot of boreholes, some have a lot of geophysical research, some have none of this. So you have these discrepancies between the regions. So maybe Vesa and Blondin can develop this further.
Yeah, well, maybe I'm a little bit spoiled here in Finland because our data coverage is so good. Yeah, it takes long time to acquire data, and data is really expensive. And I have been wondering a long time that maybe we could do this together with the industry, in some kind of a joint venture together with the industry, so that it wouldn't necessarily be only a role for the national surveys to collect the data. I mean, at least in Finland, the industry reports their exploration data, and they give the exploration data at the end when they report their exploration licenses. So at the end, the data comes public, but it takes long time. But there could maybe some other ways to get the data faster for use to everybody. It would be beneficial for everybody, for the next mining company coming and doing exploration as well. And for the regional surveys as well, I mean, there might be possibilities to do regional surveys together with the industry in some sort of joint venture type of agreement, so that they would have access to the data during the first couple of years before it's public.
And also, just for France, there is some aspects in one country. You could have some area covered historically, and you can have very good data sets. But some of the other regions are not covered or were not covered in the past by inventory. So the key aspects is to get homogeneous data at not only at the European scale, but at the country scale. And that could be a challenge. So yeah, I think it's a very challenging thing.
I would also emphasize the importance of collecting and archives of samples. That the thing at least we envy the Scandinavian countries, because they have a really good archives of drill cores and everything. And because in the past we didn't have this at our region, so if you have samples, drill cores, everything, you can always go back, look, reanalyze, reinterpret everything. So that's really, really important. So because as Vesa said, the exploration is very expensive, the collection of the data is very expensive, but then the archive is not so expensive as the first two parts. So
yeah,
because I have my personal experience, I used to be a exploration geologist in Montenegro for a lead zinc project, and we drilled, I don't know, 5 kilometers of core, and then the crisis in 2015 came and the project was put on hold, and in 1 year they throw all the cores away. So that was one of the saddest days of my life, because I spent years and years to collect this course, and when I leave the project, I said, archive the core. That's the most important. But they.
And so in Scandinavian countries, that's done more often.
Yes.
What about in France?
It should be.
Yeah.
Okay, so I see that time is running. So maybe I'd like to check if anyone in the audience has any questions. You're welcome to pose them to our experts today. So we're going to leave that option available.
So there is one question on the chat.
Okay, great. Would you like to read it off, Capucine?
Yes, sure. So the question is, are mining companies willing to collaborate on projects that benefit in the long term, such as fundamental research projects on geological knowledge?
I think this is related to what you were mentioning, Vesa, about the potential for private companies to publicly declare the exploration data they produce.
Yeah, sorry, could you repeat the question?
Yeah, I can read it off again.
Yeah.
So the question is, are mining companies willing to collaborate on projects that benefit in the long term, such as fundamental research projects on geological knowledge?
Yeah, sure. In many of the European Union funded projects, we do have mining companies involved. So yes, they are keen on participating in research, and I hope that this continues also. Yeah, definitely.
Blandine or Clement, do you have anything you'd like to add on that point?
Yeah, in France and in Europe, the Belgium is really involved at the policy, the public policy development, but we do the link with the industry, and so we try to involve them in most of the research projects that we have in order to get application and R&D application. So yeah.
My experience is that there are, let's say, my percent is 10% of the mining companies are more than willing to cooperate, and I call them progressive mining companies, that they know they have a strong research departments and so on, and they are very interested to connect with science. But for most of all, it's not the main goal to cooperate. If you contact them and if you do some talking, then they are, but they are this is not a primary concern for them. So in most cases, but you have this, I don't know, 10% of companies which are really progressive in that end.
Great, good to hear. So now we wanted to kind of, unless there's any other questions from the audience, I guess we can move towards the final point of discussion, which is that we'd like to hear from all three of the geologists present today about if there's any specific region that you think is particularly promising to boost the supply of European critical raw materials. And then if you could tell us what materials that region is able to produce and what technologies those materials are able to support. And then if you could tell us about if there's any active projects going on in that particular region. So maybe we can start with Vesa and then move around between all three of our panelists.
Okay. I could mention that in northern Finland, we do have a region in Ostrobothnia, which is potential for lithium, and there is a very good advanced project which is run by a company called Keliber, and it's actually nowadays owned by a South African company called Sibanye Stillwater. And I suppose their project is advanced so that they have pretty much all the permits that they need to open the mine. So they are really working on the project so that they can start planning to build the mine and all the other facilities there. And in fact, Keliber is one of the partners in our project, in EIS project. So this is, of course, one of the important metals or minerals for EU's battery industry.
Great, thank you. Blondine, is there any particular region that you think is promising?
In France?
Yes, or in Europe if you have experience with that as well.
So regarding, it will be also on lithium, because lithium is really important driver now about the metal market. So in France, there is the French Massif Central, which was historically explored for lithium. And there is a promising project, especially with the Beauvoir and Chassière deposits. And so this is for lithium, and there is pegmatite just around. So there is a district for lithium in this area that could be very interesting in the near future. And it's also for lithium-ion batteries.
Okay, great. And you mentioned that project is being developed now?
It's not developed, it's explored by Imerys. Okay. And Imerys also worked a lot with the Belgium on R&D applications in several research projects.
Great. And what about you, Clement? Is there any particular region that really excites you?
Yeah, of course. That's I would say Balkan region. So Southeast Europe is really promising because of the geological setting and the history. You all probably heard about the lithium project in Loznica. That's a big protest were then last year. But not only this, there are also bauxites. Still, there are some active mines of bauxites in the Balkan, and also polymetallic ores. Some really good discoveries in last few years. But beside this primary deposits, I would emphasize the secondary raw materials, because on the Balkan region is more than 270 million tons of metallurgical waste or the mining waste, which can be reworked. So that's, I think, that one of the most promising things.
Great. Yeah, I totally agree that I think extractive waste and legacy waste sites are something where that it can really be a win-win situation as well to recover critical metals from them. Great.
Yeah.
So I see. Is there anything that any of our panelists wanted to add before we move towards closing the session?
I don't know, I would invite all the participants to see the EGDI website, where you can see all the ore deposits in Europe and so on, and some basic data.
Great. I think we can find that and send that in the chat. The EGDI?
EGDI,
website?
yeah.
Great. So we'll send that over in the chat if Capucine and Ella, you can manage to find that. And otherwise, yeah, I'd like to thank again all of our panelists for taking part in the discussion today. I think it's been a really fruitful and insightful discussion about European geology. So we've seen that there's still a long ways to go in terms of harmonizing European geological data, in terms of really working in close collaboration with the private sector and also with actors in the public sector as well, in order to speed up supply of European critical metals. But we've seen also that there's quite a lot of potential across Europe to become more self-sufficient in some of the materials that we need for the energy transition. So I know lithium was mentioned a few times today, bauxite and several other materials. We've seen that there's been still quite a long ways to go in terms of harmonizing data, in terms of making sure that it's kept up to date. So it's great to see that different experts across Europe are working on that topic. And so, yeah, we will invite everyone to continue following these different projects as they advance. And we've sent over the link to the EGDI website as well, so feel free to take a look at that. And I'd like to thank everyone for taking part, and thank all the audience members as well. I think we've all learned a lot over these 3 webinars, so I will sign off with that. Thank you very much.
Thank you and enjoy.
Thank you.
Thank you.
Bye.